All right, so not your spaces. Okay. All right. So all of those recordings, I will put the YouTube link in this table. Okay. So right now, so we don't have anything, but starting, let's say next week, you will have. So this is the week 1, 2, and then day 1, day 2. For each week, we have 2 days, 1 and 2. Likewise, there will be a link over here. Okay. All right. So that's that. So go back. All right. So this is so see that this like title. So under that, that's where we have the learning material we learn in the class. Okay. So like including the side book, and I highly recommend there's an instructional resource page. So side book is our main textbook, but if you want other resources, we suggest a bunch of resources, and we put a page of those. Okay? So please go over here and then read through watch these resources as well. Okay? So that's a great set of external resources other than the site. Site is our main textbook. All right. So that's that, and then and then starting today, you will see that, and you can see that there are two graded team discussions. They are not published yet, and then you'll see like one quiz, two quizzes as well, right? So um, right. So basically, um, right. So these are basically gonna get published on the same day. Just before we start them, I will publish them, right? So it's basically as designed so that I didn't want to, spoil it for you because for the discussion, they're designed for the discussion, right? The two video quizzes, right? One for each day, and then the two team discussions. So you're gonna basically do it today as well. You're gonna pair up, make a team, and then do it today. Okay. All right. So and that's about that. In the end, right here, that's where basically you're gonna apply what you learn in that particular module. So that's the idea of learning, right? We learn something and then we solve a problem using that, right? So that's where usually the programming assignment or the assignment today sits right here, right? So so and then this is the assignment for this module, and then there's a survey there, and then this one is important module reflection. What's a reflection? Yeah, review, right? So we reflect, right? So we reflect our own actions sometimes, right? So research has shown that when students do a reflection on their own previous learning and correct, the learning outcome is way better. So this is that reflection. So I created a reflection survey for you, and you basically do it. And also, you also can submit really good feedback for me as well in there. So it's a benefit for me as well to correct myself, right? And then you reflect and then submit the survey, right? It's these are all of these. We're gonna come back to that. So this reflection and all the discussion are sitting in an assessment called community learning activity. Okay, so 50% weight there for you, your submission. Okay, all right. And in the end, we have the summary page. It's a page like the overview page. It's basically saying that okay, so you did this, so you learned this, right? And then there's a recap, like sorry, like like check page that whether you submitted all of those. Make sure you submitted all of these things. Okay. And in the end, it's gonna tells you what you are getting into the next module. So you basically, when you click next over here, you will go to module 2. That's it. So I highly recommend use this previous and next button to go back and forth in module structure. You don't have to go always to click on modules and then start that, right? If you follow this previous and next button, you will follow the module structure that I have shown you. Okay. Questions? Yes. So could it be safe to say, like on the summary, just go straight to that instead of meaning just go straight to the summary on each module? Well, so this is the basically this is the end summary, right? So what you should go is that is this one, the overview page. This is the one. This is the page that you should go. That's the one very first thing at the module, right? So start from there. Start from there, and then go next. And in the end, you will reach the summary. Okay. Yes. I think what you might be asking is like if we come back to it, like if we get halfway through and we come back to it, we can go to module and go to where we are. But if we're working on something, we can just go to. Yeah, I mean, yeah. So every item has the next button. So when you finish that item, you click next, you go to the next. Likewise. Yes. So you'll be like covering this every week, and then we'll go home and like kind of just review it tomorrow. Yes. Yep. So basically, so when you complete the module, that's what you would do. Like you view a page, click the next button, you go to the next page, do the assignment, you finish that, you click next. Likewise, it will basically the next action will follow each one after the other, each item in the module. Okay. So you don't have to always go in here, and you can follow the next and complete uh, one by one. Okay. Other questions? Right, so we still have 8 minutes to the break. All right, so that's the module. So starting today, you're gonna get into that process from the day one. Okay? So it's really important actually. Okay? So it's good to get a typical class picture from the day one. So you're gonna get it. Okay? All right. So I'm gonna go. Let's see. I'm gonna explain these two that I will be uh, posting today. One, not this one. Sorry, right here. Sorry. Um, so I'll be publishing this one after the break. So this team discussion, we're gonna pair up and do it. And then what will happen next class days? I'm going to do it in front of everyone as a discussion. So you're gonna try out it today, okay? As a team, pairs, and then come next class day morning, I will do it in front of you as a discussion. So it will take about 20-30 minutes to take about that much. Okay? Maybe not for today's one, because in last class everyone did it actually in the classes. Does it have to be two? No, it doesn't. It can be three or four as well because last class, because there were not enough people for pairing up, some group had three. So don't worry too much about it. Yeah. Yeah. And then what else? Oh, this one graded. So these are the graded team discussions. There's one here and then another one here. That's for the Thursday class. Okay. So I tend to design these in a way that will be helpful to you doing the assignment. Okay? And you will definitely see when we do the team discussion on Thursday, how to make a smoothie one, is we basically ask a similar question in the assignment down below. So that will help you because we are kind of already doing an example in the class. Okay? All right, and the next one. This discussion, the graded discussion. So that's for you, individual. So That's the individual discussion. Okay. So basically, you go there and then post, and then others make a reply. So that's basically complete submission. Okay. All right. So that's that way we have three discussions per week. Okay. One we do it in the class. Sorry, two we do it in the class, the team months, and then the other one, graded discussion, you do it by yourself, maybe at home. Okay. All right. All right. So any question, guys? Yes. Yeah, so we should be seeing these things on our. Yeah. We're not seeing all right, so the unpublished one, you will have. Oh, okay, okay. Then unpublished, right? All right, all right. So I will publish in a moment. All right. Okay. Yeah. So the reason they are not published is basically they are needed for the lesson right now. So are you want to spoil it before? That's fine. Okay. Yes.
Just wanted to make sure that the individual discussion, like post and response, that's due Saturdays.
Yes, that's due Saturday. Well, no, sorry, I think it's better. The two team discussions due Saturday. This one due Friday. Friday night. All right.
So
We're gonna do after the break. Oh yeah. So we will watch the video, then after we will start. All right. Let me quickly go to, so I'm gonna start going over the syllabus. Okay. So I'm not gonna go over the syllabus alone. You guys should read it. Take time to read it. Okay. I'll skim through some of the important topics. Okay. Um, all right. So this the class information. The section is 7. This is ERN. Um, these are my information, and then this is important. The learning objective. Okay. So you should expect end of this course. You should have all of these 5 capabilities. So these dates are important. Okay. So like for example, the last day to drop. These are all your responsibility. If you want to drop this class, this is the final day. After that, you will get a lesser grade based on your score in the canvas. Okay. And yeah. So so take a note on that. Um, the meeting times. And then I will change this times, guys. This to Friday 11, sorry, 10 to 11, the office hours. I have decided to change that to. I had to change this because last semester I was in a hiring committee and a committee met Friday morning for the interviews candidates. But we don't have this semester, so I'm back to 10 to 11. Okay. Um, all right. So this is my guarantee. Um, Within a weekday, I will respond to your question within 24 hours. Okay? My promise. Okay? And then if you have a common question, where should you should ask? Or you can ask it, yeah. In let's say online, where should you ask? Let's say you see a question that applies to everyone else in the class. Like they say, I made a mistake, I made a spelling mistake. Uh, so where do you report it? One discussion board. Good. Yeah. Yes.
Q&A.
General Q&A. Sure. Yes, that's where I should go. Okay. So and then you also make sure to subscribe to the class notification, and you will also get an email. For example, whenever I make an announcement, you will also get an email, but you have to set this up in Canvas, right? Make sure to do that. So it's not a good thing if you miss one of my yeah, it's our announcement, right? Sometimes most of those are critical, right? If you miss them, it's not good, right? So please don't let that happen. Um, and then I'll try my best to give you guys feedback and then grade them and then timely, okay? And then I have 4 TAs and then they are really good at giving feedback and they will also when they grade give you guys feedback. Okay? So I take communication with you really seriously. Okay? All right. Um, there's some statements, and then you guys should read them. So tutors card should be get going by the end of next week. Okay, so they are right here. Okay? So and it's a great resource from CS department. Okay. Um, so let's go to. Okay, it's 12. So let's get a 5 minutes break. 5 minutes. So let's see we are around 12:07. Okay. We're gonna watch a video. How was it? How was it?
I was in this class last semester.
I remember you. I told you. Oh, okay. So you traveled. Okay. I remember you actually. Yeah. You attended first class, right? Yeah.
Yeah.
And also we had. Like this. Most, I mean, they should get to. We have a good. Okay. Yeah. I have a feeling that because we also have.
Yeah.
So make sure to keep the communication going. So don't just you apply right now. Don't do like this. So, you know, you can ask a question. You know, like it's not. I think don't you watch that communication going just because you apply. And you will continue more relationship. That's how you build relationship, right? So by the time they leave them, you already have a nice relationship.
Right. I mean, you sound a little weird if you're like, I'm watching presentation. Like, let's just hear this from us.
That's what I actually when I was
Yeah.
you can
Are you gonna say I used to not realize that they tried all this like the argument of like capitalism to socialism has been, you know, you like, yeah, all these platforms and you think it's something you happy with Trump is like just GMO he's fucking orange and fucking coffee, you know what I mean? The fact that he's president is insane. I watched this documentary on it. I didn't pay attention to him the first time. I had no idea. And then he lost, and I sort of noticed that. I noticed that, like, he was like, oh, like, I'm gonna win. And then that happened. Yeah, that was great. But then when he won the second time, he came out with this theory about how he won the first time. And he was also fucking and he was like, And when he did that debate, after the debate, I watched it. I felt bad. I felt so bad. There's so he's falling off bicycles. He can't go upstairs. Like, come on, bro. Take it easy, man. Like, but after that debate, CNN came on and they were like, we need to find so we need to, he's a fucking, he is a retard, you know what I mean? But then the Republicans were saying he's fucking in the crime, he's a fucking retard. And they were like, no, 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 behind closed doors, he's fucking, you sharp as fucking whip, you want. And after that, they were like, no, it's getting pretty fucking bad. But it was towards the end, like it was all over fucking, you know what I mean? He was acting president anyway. But then Ronnie, although Ronnie was like, there's no way she's gonna let you. It was so amazing. Well, that's like 4 years to figure out that Biden is too old without it. And that was insane. And that was actually something that like one of them was like, it was like Biden was like, I can go through it all. Like, you feel like you're just stuttering his words. I was so awkward. But no, one of the things that he said also is he said the day that I'm inaugurated, not the day that I the day that yeah, the day that I win, not the day that I'm inaugurated. That's the day that the war Ukraine will end. And that's important. And then just a couple months ago, he said, they're on the news, we're almost there. The war's gonna end any day. And then Putin Ukraine like the next day. And it was more of a fuck you than Trump. And actually about 20 more. But now they're saying that he what he was saying last night is the same thing. He's like, well, very close to the end of the war in Ukraine. It's like you can say that Trump is a fucking scumbag. But the who I really wonder how he sleeps tonight is fucking Putin. Like that could be president for 4 years. Like that is literally said. Because you're like, I don't understand. Oh no, he's not. It's like that mattress for the court. I was like, how did you do that? I was like, how did you go mattress for the court? That's like, oh no, no. So, dude, like, I don't understand, dude. Like, does he live like just like in hot tubs? Like, I don't understand. Like, what does a person do once they get that much power? Like, do they just stay in the hot tub 24/7 with like a pile of
All right, guys. All right, so you're gonna watch that video. It's about all right, guys. I'm just gonna publish it. Okay. Could you all refresh the module view because I just published it, right? So you need to refresh the module view. Well, not that one. Okay, sorry. Um, Let me quickly. I think. Oh man, I think refresh this. No, I'm gonna show you what it is. Yeah, right here. Okay. Could you all refresh now? One more time. Sorry. All right. You should all see this one. Extra credit video quiz. Peer instruction. If you don't see it, then refresh one more time. So, and I'm gonna actually watch this video. Okay. All right. So what is peer instruction? Read through this text, and I will tell you what is peer instruction, but its name suggests basically you guys are going to help each other out and learn in the class. Okay. So that's peer means you guys, right? Instruction means learning, right? So peer instruction is mainly that. It's one of the best learning techniques, and we're gonna try to implement that in the class doing the group team discussions. Okay, so that's the goal. Yes. So refresh the module view, and you should see this one now. Yeah, yeah. And we can actually watch this video, but I'm going to play it, and you can probably find the answer after watching the video. Okay? Surely, can you help me? All right. So this is a short video. So video kind of suggests the way to implement it using like a multiple choice quizzes. But our class is a discussion. Okay. So basically, like do something like coding. When we start coding in week 4 we start coding in the class. Okay, like learning to code in the class. Um, until then, it's conceptual topics, conceptual topics. Okay. So so let's watch this video. Okay. So I'm going to talk about. Oh yes. It's model one. Model one. No, I'm gonna play the quiz. And if you guys also try to play, then it's gonna be a mess here, right? Because you can't hear the voices, right? So if you don't have to play, you can watch it over here when I play it. Okay. All right. Ready? Everyone found the quiz? Raise your hand if you can find it. All right.
Hi, I'm Julie Schell, and I'm probably one of the biggest peer instruction fans out there today. In this quick video, I'm going to give you a 2-minute primer on what and how of peer instruction. If you open the doors to any classroom where peer instruction is being used, you'll see a highly interactive, engaged learning environment where students and their instructors are having a lot of fun while they're engaged in deep learning. Originally developed for use in physics classrooms at Harvard University, peer instruction is now used across the disciplines in classrooms all over the world. And that's because over 20 years of research supports that students learn best when they're in an interactive teaching and learning environment. Peer instruction is a research-based, student-centered pedagogy developed by Professor Eric Mazur in the 1990s at Harvard University. Peer instruction works best when implemented through a flipped learning approach, where students prepare for deeper learning during class time before class meets, at home or in study groups. Then when they get to the classroom the next day, they interact with their peers and their teachers to apply what they learned in those pre-class assignments. Teachers structure that class time using concept tests. In fact, the concept test is the centerpiece of peer instruction. It's a question designed to help elicit, confront, and resolve student misunderstandings or misconceptions about the subject matter that they're learning. So now that we've talked about the what, let's talk about the how. You implement peer instruction through a simple 7-step sequence. The first step is to provide a 2 to 5 minute mini lecture on a particular concept or topic that students are struggling with or that's really important for them to learn. Second, instructors pose a question or the concept test. These concept tests can be multiple choice or short answer. It doesn't matter. The third step is one of the most important, and it's one that many instructors skip when they're implementing peer instruction for the first time. In that third step, you need to give students time to think about their answer on their own first. The fourth step is to collect students' responses using a classroom response system such as clickers or flashcards. And in this step, it's really important that you don't reveal or describe the results of the vote for the students. In the fifth step, you want to cue students to find a neighbor with a different response and convince them of their answer. In the sixth step, again, without revealing the results to the students, ask them to commit to a final answer. Finally, in the seventh step, you can reveal the responses and the right answer and come to closure through some kind of class-wide discussion about both the answer and the reasoning behind it. And that's peer instruction in 2 minutes. You can learn more about pre-class assignments,
Alright,
concept
guys.
tests, and peer
Let's stop
instruction
right here.
at the Peer Instruction blog,
So,
blog.peerinstruction.net. And you can find other users in your subject matter area or at your school or
so basically what we will do in our class is have that group discussion. You guys get together and do it and submit. Okay? And then come next day, I explain it to the class again, like with all of you, and then as a discussion, we do it first, and then go on to that day of it. Got it? All right. So today, so probably around 12:30, 35, maybe 40, I'll open that, and then you will get together and do it. Right. So and then entire last class got it done actually at the end of the class. So it's a small thing today we're gonna do because it's our first day. But as we move along, we'll actually solve a real problem that came out from what we learned in the class and we solved it. Okay. All right. That's why I told you guys at the very first we are bringing doing into the class so that it's not that in a boring way. Okay. All right. So now we are going to do the some side of things because that's our lesson, right? So so let's go to the side book. So I'm gonna go to the this one and then start the side book. So you already know how to do it, right? So we click this button, right? So always whenever you start a new chapter, this new module, right? Click this button from canvas and then go to side book because side book allows you to finish all the chapters without going into canvas. But the two systems need to talk to each other, right? Because Cybook need to update your grades in Canvas, right? So they use cookies, browser cookies to communicate behind the scenes. So if you click this button, that process, the cookie generation process is guaranteed. So if you do other way, sometimes there may be hiccups, and then now you don't see different grade in Canvas, different grade in Cybook. Yes.
What you're saying is, for example, I finished chapter one. Now I want to move on to chapter two to go ahead.
Yeah.
I don't have to go to module two to chapter two.
Yeah.
Update to chapter
Yeah.
yeah. Can just keep going.
No, you can keep going, but I recommend going back to Canvas and pick the reading and participation activity assignment like this one in module 2 and pick this box.
Just to have a reassurance.
Yeah, just to have a
Yeah, because I'm trying to bookmark this, just thinking that I could go back to it like whenever, but that would maybe cause problems if I shut my computer down or.
Yeah, those things are there, right? Yeah. All right. Okay. So let's click on this button. So this is our very first cybook chapter. Okay. So and it'll actually when you click on that button, it will take you to the first section of that chapter. Okay. So all right, see that? It momentarily shows you the view, and but it will go to correct section, which is the first one. Okay. All right. So well, I'm not going to go over each section in depth. Why? Well, the thing is, we don't have enough time, right? So there are a lot of sections, and this chapter we don't have many, but go check this second module. We have like 20 sections. So that's why this is an interactive book, right? When you do the side book, you will learn them, right? And you can also ask me if you have any questions. But I will pick the section that I decide that is difficult for you, and then I will spend time on those. Right? So I have experience on those. Yes. have to come here to do the side move, right? You should come here to participate in the leg jack.
So we all the sections.
Yeah, I mean, not all. Like you can do it after the class as well, but at least try to get a head start so that you get to some familiarity when I talk about this.
No, no, I'm saying like, I don't know.
Oh yeah, yeah. So you have to fix all of it.
Okay, okay.
Yeah, because that's part of your assessment, right?
Yes.
Part of your assessment. Yes.
So the first time you're sending in a head essentially, but you don't expect us to come in on Monday morning after reading chapter 3 and
No, I'm not gonna judge you like that. No,
have a full
no,
breakdown.
no, no, no. So I'm not gonna judge you like that. No, I think you have very less experience on that, and I'm gonna cover a very, very important topic that you will face problems inside. Okay, that's what I'm.
Okay.
Because going over each topic in detail, you don't have enough time, and then it will be boring and then you are
If you focus on the main
Well, each class has its own chapter or is one chapter per week?
each no one chapter per week.
Okay,
So you have an entire week to finish the
okay,
chapter.
okay, got it, got it.
So, yeah, I mean, you have entire week to finish the entire chapters, but I appreciate if you can get a head start, so you kind of have familiarity with the topic that we're going to discuss. All right. So, yeah, so this is a computer intro to computer science class. So, should I keep the light or should I? It's good, yeah, right? So. And then you can see that this is one of the very first computer, this big picture, right? It's the in 1940s, and you can see that the entire room filled the computer, right? And then you can see that the transistor got invented, right, in the 50s, and well, it became something like this, right? So, and you can see that I can tell you that this thing in the fingertip is thousands of times powerful than this entire room computer. Can you imagine that, right? So, and what the device function was really similar, right? It's actually a switch like this one, this light switch. It switches on with one in the language, and then it switches off with zero in the language. So the binary zero and one, right? So, but the device, the switch itself was big in the early computers like 1940s, like this big, right? So now we don't even see it in a naked eye. It's in nanometer scale right now, right? So if you if you take a human hair and keep splitting it up to 10,000 times, that's kind of micro and nanometer scale. With basic naked, we cannot see in the naked eye. We need a powerful microscope like a electron microscope to see the device. So that's actually a whole bunch of devices in the finger, right? So, but what is the name we call the early transistors in the 40s? Anyone stumble upon the name? The early switch, the name of the early switch that we used in the 40s. You may have seen some, like, antique radios and TVs that's like, this big boxes, right? Yes, vacuum tubes, right? So, so they are also valves. Why we call them valves? Because one direction they can transmit current, but the other direction it blocks. Like water flowing in a single one direction, right? It's a valve. So we also call them valves. Nowadays we call them diodes or transistors, both in the same category. Right? Then we use silicon. So how far we can go? Making smaller and smaller. Can we go forever? Or we have any stuff? So right now we're in nanometer scale. So 10 to the 9, negative 9 meters.
So basically we're one of the qubits.
That's quantum, right? Yeah, yeah, yeah. Yeah.
read about Moore's law before, but I mean, why? I mean, there must be a limit, but why does it? Why do we have to? Like, why can we? Why can we just skip ahead? Why once we have the technology, why couldn't we be like, okay, now let's just make it super duper small, and okay, let's make it twice as small.
Yeah. So some say quantum computing would be the next leap, but still, we're still really in infancy of quantum computing. But I would say, we use silicon in transistors these days, right? The silicon uh, keep only its properties until we have six silicon atoms together. We call it a single crystal of silicon. We go beyond that, silicon loses all of its properties. So that means we cannot have a transistor beyond six silicon atoms. So that's the final frontier. That's it. We are really close to that. 2 nanometers means we are really in that range right now. Okay?
Right. So you're saying that it's like the isotope of silicon.
Yeah.
You need that isotope, but then
Yeah.
quantum computers would be the limit because quantum computers use electrons.
Yeah.
As the
Yeah. So quantum computing can have the next step.
But there's
Yes.
like a lot of
I'm just trying to get clarification on the
Mhm.
whole thing.
Mhm.
I'm new to all this as
Mhm.
well, but when you put it to scale, that computer
Mhm.
fits on a whole room in the 1940s and it's slowly transitioning into what is on that finger.
Yeah.
So what is on that finger
Yep.
isn't all the components that
Yeah.
to make a computer, right?
Yeah. Yeah.
It's because I'm to a certain degree no, but there's certain components that you need for a computer to work, right?
Yep.
They're saying all of this.
So, well, yeah. So, like power cable and those stuff, you have to connect this. But that's the processor. Yeah.
That has the process.
Yeah, that's the brain. More capable than that big room. Yeah.
That has all of it together.
Yep. Yeah. Now, if you take your smartphone, you have those things like that. That's small, right?
Okay.
Yeah.
But there's many of them.
Yeah. There are many of them. Yes. We have different purposes. Yeah. Yes.
it's like a
Yeah. All right.
But I do have a question about that. So that little one that was on his finger, like, can I plug that, like, wire that up, and then that little thing alone has as much computing power as.
Yep.
there's-
Yeah. Yep. That's how. Yeah. I mean, that's a big leap actually. Yeah. I mean, that's the invention of transistor. Happened in the 50s, and then it kept getting smaller and smaller. All right, so we're gonna go to the. So you guys should, guys. Okay. So don't wait for me to do this thing with you guys. Okay. You guys to do. Right. So again, interactive side of it. Read and do it. Okay. So I will cherry pick things to do in the class that I would think that it will be difficult for you, and I'm going to explain it. Okay. So otherwise, we will not finish a chapter in 1 week. That's why. Okay. All right, so I'm gonna go to the next one. So this is historical. Um, yeah, and then if you some history, but this is not the whole history. So this guy, this is the weaver, right? So this guy had a loom, and then he used a punch card to change from one pattern, weaving pattern to the next. So he didn't manually change the loom. He used a card and then insert the card and then the loom now has a different pattern. Gives out different pattern. So it's kind of a first mechanical computer, but some say, but this happened even way before, in the 9th century, in modern day Iran actually, Iran or Iraq probably. So I'm talking about the hard drive, the first hard drive, and then the what do you call um, re the reading from it, right? So can anyone did anyone encounter that person who they are? Anyone? So ancient Greeks also did something similar, but they use cryptography, right? You may have heard Caesar cipher, right? So they use cryptography to uh, encrypt a message and pass it to someone else. So that also related, but it's not a hard drive, right? It's a messaging technique. So these people, they actually call Benamusa brothers, and I actually have it over here, right? Benamusa brothers. So these were two brothers, and then they actually did some. They were astronomers, but they used a recording device. I'll send the link to that. There's a nice video on it. Um, they stored music on a drum-based hard disk and played the hard disk all mechanical. Literally were not invented by that time, actually, and cranked it and rotated them, and then the device replayed the music. So it's like a gramophone thing, but happened in the ninth century. Right? So, yeah, I'll send the video to you guys. You guys can watch it. Okay. So we're gonna continue, guys. So I'm gonna. So this guy is also important. The Alan Turing. So we call this the father of modern computer, right? So he actually built this machine to decrypt Enigma messages of the Nazis, right? So and he helped deciphering a lot of encrypted messages in Nazi Germany. Okay. And then one of the biggest name is Grace Hopper. She actually suggested and also I think use first coding language, right? So she suggested we should use English for coding, not zeros and ones. So hence the first assembly language came, and then after like COBOL, like higher language came. Okay. So and she is also the person who first coined the name bug, the bug, because that was a big like room size machine, and then that bug was short circuiting a transistor, like a valve, and causing an issue. So she called the bug and put it on the tape and recorded that, saying the bug. So hence the first name of bug, computer bug name, right? So that's where it's coined.
So, so they not
Yeah, the mod was the yep. Yeah. All right, so we're gonna go to the next one. And I also suggest guys a lot of readings, extra reading for you guys to read. Feel free to check them out as well. Recommended, yeah, yeah. But it's up to you. They're optional. Okay. All right. So I think we are fine with timing. Okay. So computers all around us. We see that like these are definitely seen as computers, right? Your laptop, the tablet, the desktop, and then the smartphone is actually a computer itself. Okay? But there are other computers too, right? So where else do we have computers? Yeah, elevator panel. There's a computer. Yeah, it's a microcontroller there, right? Yes. A lot of cars have computers inside, right? Plane. There's a really advanced computer there in every plane, right? So yes. Yeah, washing machine. They even talking to apps, right? You can control it by an app. We call them Internet of Things because through the internet we can communicate with them. Yes. Refrigerators, yeah, there are many devices, and then vacuum cleaners, those things are there, right? And then that's this one, right? Okay. So, we can go to the next topic. I will try to go like as a summarization of each section, but I will cherry pick to go in depth. Okay, which is this one. Yes.
So like if you like, let's say you had like a computer or some kind of like a part that like it turned the amount of electricity coming through it
coded and installed in the console. Use it, the device used it. Yeah. And I don't know whether you can program the computer these days. Maybe some manufacturers would allow, but they do it through an app. Yeah.
Is turning it on or off.
Yeah.
Remotely, not required.
Yeah. Yep. All right. So this is an important topic, so we're gonna spend some time. Okay. All right. So so this is about solving a problem using the program. Okay. So so this is problem solving using computers. Before that, let's talk about solving problems in the real world. Okay. So I had this really big problem on Sunday, this Sunday actually. So I found out that my kitchen sink is not working, right? So I removed the US screen, so that means you know where the problem is down the line, right? So that's the problem now, the non-working kitchen sink. So what do you guys think the solution would be?
It sounds like mechanical problems that get down to the pipe.
How do we get down to the pipe? Well, it's down the line inside, yeah.
Take it out, yeah.
So what do we do? So that thing called snake, right? You may have heard this. You can send the wire, like a metal wire, string, and you crank it and gradually you can spin it. And if we have something plugged and you crank it up and then it's gonna break it and break the blockage. So I found out that 13 feet down the line, there's a blockage. So I used that and then solved the problem. All right, my question is, what are my inputs? What is the process? What was the output? Only change the concept, but this is real physical problem, not programming. What was the input? Yeah, that's the problem, right? That's the problem. So that's not the input. Yeah, that's a good one. Yeah. Anyone else?
Probably trying to use the sink. Put
Yeah,
water
like,
into the drain.
yeah, that's one input. There are many inputs there, right? Because my perceive gets the input, right? So the snake itself is one of my inputs. Because I use that.
The problem is the initial output, right? So when the system's in place, and normally
Yeah.
the output is the water goes down.
Yeah.
And you're getting a negative output, which is
Yeah.
coming up. So then your next input would be, okay, I gotta put the thing.
Yeah. Yeah. So basically, yeah. So there are maybe like depending on your way of you interpret it, it can be different as well. But you know, there are obvious inputs, right? Like you know, the way I see it, that you know, if the U is working, right? So nothing dropped there. Those are all inputs, right? And then the thing that I use, that's also an input. And then what the process I use is, what's the process I use?
The function of the state.
Yeah, that's the process. So we use that to unplug it, right? And then what was the output?
Working sink.
Working thing, right? So the water is draining, was draining. What took entire day for almost. All right. So, all right. So now we're getting into computer program. So every computer program, every computer, the problem we solve in a program, we have these three things, and it is um, um, it's part of the expected skill set that you would gain from this class to recognize these three things in order to solve the problem. Okay? And down the line of this course, I'm going to show you a real good problem solving technique that you can apply to use these three things and solve the problem. Okay? That means first step is you should be able to recognize these three things in the problem based on the surrounding context of the problem first before you and that you can use to um, solve problem in computer science. Okay? That comes in with the form where we're going to learn to code first in the class. Okay? The intro to Python, the first chapter 4. Okay? All right. So so that's that, and then sorry. Um, I'm gonna jump to the next one. So this one. All right. The process of solving problems using the computer is called computational thinking. Okay. So right, and then before we solve, before we write code, right? So we kind of, let's say we found out the solution, right? And we call the algorithm basically the steps, English steps, right? Instruction that would solve the problem. We call it algorithm. Why finding that is very important first before writing code. So here's a question again. Okay? See the last sentence, a sequence of instructions that solve a problem called an algorithm. So that sequence of instructions are in English, not in Python. Remember, Python is a programming language, right? What is English? Natural language, right? We call it natural language, right? Like Mandarin, Spanish, all sort of the natural languages, right? So, so algorithms should come in English. So, medium of this class is in English, so let's stick to English. So, why writing that algorithm is very important first. Yes.
Well, I see the algorithm kind of like the recipe for like taking
Yes.
meals.
Yeah. So you follow the recipe and you get the end product, right? Yeah. Correct. Yes.
So yeah, so the algorithm is the recipe in English, and the code is that recipe in code.
Yeah. So what's the process making algorithm to the code? Why do you call it?
Uh,
Anyone? Anyone? You are almost right, but it's a good point you are making. Programming, all synonyms, real good synonyms. I call it translation. Why translation? Because the text in algorithm are in English, right? We need to translate that English into code. So that's the process we're going to learn for. So I also already said unfair technique will definitely help you how to get there easily. Okay? Yes.
so you know, because when people use the word algorithm a lot today, like when they refer to like getting people to uh, like watch more stuff. So like I thought of the algorithm as like math, but the algorithm is like literally like just the companies are like, okay, we want them to watch one more video. So that's the algorithm that code that in and then it works because people just keep looking through it.
Yeah, so some people even prefer algorithm for code as well because it's a English sort of the algorithm, but it's, I think that's a misuse to be honest. Algorithm should be in whatever the speaking language of the coder, so let's say in English, right? So and then the thing is when you learn the syntax of the language, which we will in this class, Python, you will learn how to translate. Like when you learn two languages, you know how to translate from back and forth, right? And for example, let's say you're learning Spanish and you're learning English, like you also your mother tongue is English, but let's say imagine you are learning Spanish, then you basically know how to translate between the two, right? That's what we're gonna do in this class. We're gonna learn the syntax of programming concepts in Python, and then once you have the code in algorithm in English, you will be able to translate that each of the steps in English into code because you are learning the syntax. Okay? All right.
It's sort of similar to math, where like we read it as 2 plus 2 equals 4, but really it's 2
Yeah.
symbols plus symbols, 2 symbols.
Yeah. You're right. You're right. All right, so I think we are almost done for today on the cyber quiz. Okay, so let's get into. So I'm gonna stop right here, guys. So remind me. So Thursday, I'm gonna do this one with you all. Okay, so we're gonna start from here. Okay, all right, and then we have I think three more sections in this chapter. We're gonna cover them all.
From the design book, the more for that not do or
No, this one book, the sidewalk grading and participation activities all due Monday. But don't think about this Monday. Let's say going forward, start module two, right? So try to get something done on sidewalk by Monday night for module two. Yeah. Yes. Yes, please. Because they all have points. Yeah. And you can imagine now, right? So I spend like sometime on two sections. Imagine how much time it took, right? If I try to cover all of them, spending that, you will not have enough time in one week to finish. That's why I'm cherry picking. Yeah. 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 So next class we will start from 1.5. Yeah, yeah. If you can, yes. All right, guys. So we're gonna start our next big tip. Usually we start this around 12:30, but we can do this one today in this 30 minutes. Okay. All right. So I'm gonna just publish the next one. This one, okay? So right here, this one. I just published it, guys. Could you all refresh your module view? All right. So for this one, so this is where we're gonna practice that peer instruction now. So we're gonna pair up now. Okay? So find your concept partner, and if you have discussed, you both can let's say, well, yeah, you three can get together, right? And then three of you, right? So you also will join them, okay? All right. And maybe okay, you two, and then you two. So yeah, so spare up. Yeah. Okay. And then you can ask if something from me.
yeah.
Okay.
Thanks so much.
All right. All right. All right, guys. So let me open this. I think I opened it already, right? Yeah. So this is basically about how to submit um, team discussion code and file. So, so follow me, guys. So please pair up, and I recommend um, creating study group. Don't forget about this. You don't need the US National Park name. But if you want to, you can create groups, right, in Canvas, and you can name it whatever the name you want. Okay? And then keep the pair group forever and then study together as well. Okay?
So how do
Yes.
you log in on Google?
No, it's just suggestion from me. You can give your own name. All right. So, um, so we're gonna basically, I'm gonna give you guys a couple of minutes to keep through this, but I'm going to show you how we actually so, yeah. Technically, we have to play, yeah. All right. Maybe we have enough time. We'll get it done. Okay? All right, guys. Um, all right. have your attention now? All right. So since we are running out of time, I'm going to walk you over this, and then you guys all can get together and then follow me and then get this done. Okay. For today. Okay. Other times, I'm gonna let you guys do, and then give 30 minutes at least. Okay. All right. So click on this link right here. Right, this one. Click on this link right here in the step 2. Okay. This one. Click on it. It'll take you and some code, right? So uh, don't worry about this code, but I guarantee by week 11 you'll be able to write your own code like this. That's my guarantee. For now, it's given to you. Don't worry about it. How it comes, forget about all those. Okay? So just you need to do is run it right here. Click the run button right here. Okay, and see what happens. Right, it draws a fish, right? And the few lines on the top actually drew a fish. Okay, so and again, let me tell you, I guarantee by the end of week 11, you would be able to write your own program drawing a fish like this. Okay, provided you follow the course right properly, right? That's why I'm telling you, don't worry about this code. All we want to do this today is how to post this to our discussion. That's what we're gonna learn today. Okay? So you're gonna first copy this code as text and then post to the discussion. Okay. So follow me. If you have a Windows, it's Control A to select all, like this. If you have a MacBook, it's Command A. Okay. So click on right, click on right here inside and then Control A, right? You can also right click and then select this. See that? Select all and copy and things, right? So now it's selected all. So now Control C or Command C if you have a MacBook. Okay? Command C to copy. Or you can also right click and click copy. Okay? All right. So I have Windows machine. So I'm using Windows command. If it is MacBook, probably instead of Control, Command. Okay? So now we go to the discussion and click on reply. Okay, click on reply. All right, and then paste. All right, and you can see that the formatting is not code like, right? It's like text, right? We want to change that. See that it's actually paragraph, right? So this it pasted as a paragraph, but we want to change this appearing like code. So what you all want to do is now select all again inside Control A, like I selected all, and now change the settings here, not paragraph but pre-formatted. See that over here? Solely could you go on and check whether everyone doing pre-formatted, right? See that now it's kind of the formatting got changed, right? So now it's kind of odd looking. Right? So that's your first step. So basically pretty much every this kind of assignment you will do these two steps. One, you will submit text code, then you will embed that website under the code. So let's do that part now. Okay? So in the end, right? So I have given that instruction over here on the top. Okay, so if you follow all these instructions, basically it will get done. So next step 2 is embed your code. See that? Embed your code. So to embed your code, this is your code. Okay. So I want you guys to click on save button. Right? When you save, and please don't overwrite. Okay. So that will not be a good action, but any of these two is working fine. New revision or new file. So I'm gonna click new file, and you can see that the link right here got changed. That means the new page. Okay. So click on OK, and then basically what we're gonna do is we're gonna go back to canvas, okay, and copy paste this one, okay. So I'm gonna basically copy this, all right, copy that part, control C, and then go down to my reply, and not here, okay guys, do not paste it here, because what we copied was HTML. This is still text, right? So we need to go to HTML mode. So click on here. So now this is HTML mode. Okay. So here's what I did. I click here. So you can actually toggle it back and forth. So click here one more. It's gonna be, see that it's HTML, and then if you click again, it will be text. Okay. So I'm gonna basically click here and then go to the very end and then paste. All right. Why? Because it's HTML code, so I have to paste it in HTML. So I pasted that, right? So now I have to replace that line with the link. So copy this link, Control A again, or Command A if you have a MacBook, Control C to copy, and go back to the discussion and replace this part with the link. Okay, that's it. And then if you toggle back, you will see that the page is embedded now. See that? See that? Right? So now you reply. That's it. You reply. You are done with the discussion. Right? So I just did that, and then you can see that the page is also embedded. Right? I can. You don't have to go to a different tab. I can